Okay, let's talk about Simpsons Rule today. And this is going to be fairly brief, possibly for two reasons. One, because this board is acting up. Alright, we're not going to go into a lot of detail on it. There's some pickiness to it. You do have to know it. Hopefully you'll get mostly questions on the AP where your calculator can take care of it. But what Simpsons Rule does is it given a series of points, whether these points are data or whether they're along a function, Simpsons Rule will attempt to approximate them with separate parabolas, which is a pretty good way to follow a smooth curve. So what Simpsons Rule is doing is assuming there's a parabola connecting these 2 points, and it's finding the area underneath it. The pattern is a little bit differently. Oh, a couple of conditions here. Conditions for using Simpsons Rule. 1, n has to be even. What do I mean by that n has to be even?
An even number with any number.
Well, what does n mean in this case? What does n mean? I'm not sure if I used n in the trapezoid rule, I think. In the trapezoid rule, n was our number of trapezoids. I'm just realizing I may not have defined that as well as I'd like, so I'm going to tell you. So n has to be even, so you must have an even, my battery's dying, must have an even number of intervals. So there's no such thing as a question that says, use Simpsons Rule and 3 intervals. Use Simpsons Rule and 5 intervals. It has to be an even number of intervals for this to work. And then the rule itself, okay, I can rewrite this, or I can just, we can do a data example with it. Didn't ask for one on the homework. Okay. Rule itself is a little bit weird. A and B are the beginning and end points of your interval. 3n, n is the number of intervals you've got. That will always be a even number. F of x of 0, f of x is a y value. So these are like the y's that we were using with the trapezoid rule. And notice this pattern here. It alternates 2y and 4y. Okay? So that would be, the way I was doing would be y sub 1, y sub 2, y sub 3, y sub 4. It always ends with a 4y before going back to just y by itself. It's a crazy little rule. Let's do an example of it. I know what I'm going to do. I'm going to go back to that first example we did. I realize that was a little bit of random seeming information, but are there any questions on this part so far? Okay. I prefer to tell you guys where this stuff comes from, but with Simpsons Rule, I never think it's worth it to go into too deep into it. Alright, so quick example. Just going to do y equals 4x minus x squared. This was my first trapezoid rule example. Actually, it's kind of a bad example. Well, let's do that. We'll see what you think of this example in a minute. With 4 intervals from 0 to 4. And we're going to just approximate this area. This one looks something like that. You might remember from Monday. Intervals are going to be fairly simple. Okay, if I say 4 intervals on this one, what's my delta x going to be? 1. 1. Very good. Alright, so using the notation that I got from the book, from that Simpsons rule, let's see what we're going to need to know. We are going to need to know okay, so this way. What is x sub 0? Everything going okay? Okay. What is x sub 0 going to be looking at these intervals that I've quickly drawn up here? What's my first x point that I care about?
1.
Is that where I'm going to start at 1?
Or 0?
Yeah.
Okay.
X sub 0 is going to be 0, x sub 1 equals 1,
Oh,
x sub 2 is 2, x sub 3 is going to be 3. This is kind of a bad coincidence. This pattern won't always happen. Alright, like that. These subscripts don't have to line up with the x values, I just realized that. Alright, what's f of x sub 0?
0? Yeah.
It's just 0. Excellent. I don't have the graph this time, but what's f of x sub 1?
It's 3.
3, very good. It's 4 times 1 minus 1 squared, which is 3. What's f of x sub 2?
4.
I think you're right, because that's 4 times 2 minus 4, because that's 2 squared, so that's 4. F of x sub 3? 3. If you remember from Monday, or if you just happen to know this one, God, my drawing's terrible. That's supposed to be the vertex. Yeah, F2 is the vertex, it's symmetrical, so 3 is going to be the same as 1. And what's f of x sub 4 going to be?
0.
0, yep. Okay, so according to Simpsons Rule, the integral from 0 to 4 of 4x minus x squared dx should be approximately, what did that rule say, b minus a over 3n?
Yes.
I think so. So that's 4 minus 0 over 3 times 4. That was my number of intervals, correct?
Yes.
And then that's multiplied by the first y value, which is 0, plus 4 times the next y value, which is 3, plus 2 times the next y value, which is 4, plus 4 times the next y value, which is 3, plus the last y value, not multiplied by anything, which is just 0, times my delta x, which is 1.
Wait, what about the other bit?
What did I leave out?
The 4f of x to the sub n minus 1.
You start out with just the first y value,
Yeah.
then 4 times the next y value,
Oh, that's just the thing.
then 2 times the next. You just alternate 4s and 2s.
No, but the thing below is just explaining the.
Oh, this part?
No, that.
The
4,
the xn minus
F.
1.
that.
For this?
Yeah.
Yeah.
Yeah, this just means you keep going for as many terms as you have.
Right.
So you're going to always have, it's always going to be, let me see if I can explain this a little better. If you have an even number of intervals, you're always going to have an odd number of y values to deal with. Let's call that the fence post rule. If you have 4 lengths of fence, you need 5 fence posts. Okay? So what you're going to have is a first y value that's not multiplied by anything, a last y value that's not multiplied by anything, and you're going to alternate 4, 2, 4 in between. Since you'll always have an odd number of these, it'll work. So the way that they're saying is, no matter how far you go with this, you're always going to have a first y value that's not multiplied by anything, a last one that's not, and you're going to go 4, 2, 4, 2, 4, however many times you have to, until you're the second to last one, and then you're going to stop and not multiply by anything. You don't multiply by the delta x, that's taken care of here. I totally forgot that for a moment. So even though it wouldn't have changed this answer, I was thinking of the trapezoid rule, and it was wrong of me to write that one. This takes care of your delta x right here, your b minus a divided by 3n. And what is this number going to be?
10.666666666.
So as a fraction, that would be
10 2/3.
10 2/3, which was
20/3.
20/3?
Yeah,
It's
20/3.
30. I think it's 32 over 3.
Yeah, that's 10 2/3 is 32 over 3.
No.
Okay, good with the decimals, need to work on the fraction. This 3 goes into that 10 times with the remainder 2. Let's review the third grade stuff for a moment.
Yeah, well.
Alright, now for this one, I said Simpsons Rule approximates parabolas. So let's take a quick look at something here. to another example. What is the actual integral from 0 to 4 of 4x minus x squared dx? This is a straightforward anti-differentiation problem. All you have to do is go term by term. There's no u substitution. There's nothing fancy going on. So what is the antiderivative of 4x? Cruel to ask, just coming back from break, but...
A 4x?
Yeah, anti-derived 4x.
Anti-derived is... There's an x squared.
That's what you
It's an x squared, okay.
Over 2.
There's an x squared over 2, very good. What about that 4 that was there originally?
Put it on top and then slap it out, so then it's just 2x squared.
Excellent, I'll get to that step in a minute. And now what about anti-derived x squared?
X cubed over 3.
X cubed over 3. Chris felt a little need to redeem himself there. I remembered his basic antiderivative faster. Then we put the endpoints of our interval there. And so, let's see, we are going to get...
Over 3.
Over 3, thank you. You said it correctly, and I wrote it incorrectly, so I was thinking ahead to a different step, which is a bad habit of mine. Okay. Ike also said that, I believe he used the term slap that out. I think that's the formal mathematical term. So this is going to be 2 times 4 squared minus 4 cubed over 3 minus, I put 0 in for x squared and 0 in for x cubed. That will all be 0, but I like to make sure you stop and think about it. 4 squared is 64, right?
What?
4 squared is 16, right?
32.
32.
Thinking ahead here now. That's my yes. 16 times 2. It's 32 minus
64 divided by
3. 64 divided by 3. 32 is 96 over 3.
Oh,
I'm going to make the common denominator. Minus 64 over 3. So my final answer is 32 over 3, which I can write more neatly. Does that look familiar?
Yep, it's what we just got.
Why would an approximation, why would an approximate method with only 4 intervals give us the exact same thing? We do the actual antiderivative, we get 32 over 3. We do the approximate with 32 over 3.
Is this a trick question?
Because you're using the same interval?
Nope.
Is it the same thing?
It makes, well, it's a little bit of a trick question actually. I mean, if we used a ton of intervals, we should start getting close to the right one, right? Has to do with a little throwaway comment I made since I did not prove where this comes from. I said the way Simpson rules work is it assumes that it assumes that between your data points there are parabolas. And it uses an algorithm to find what the area would be if this was the area under a parabola. So guess what happens when you use Simpson's rule on a parabola?
It works.
It works. You get the exact answer. If you use it on anything else, it's an approximation. But if you use Simpson's rule on a parabola, you get the actual integral. Similar thing, if you use the trapezoid rule on a line, you would also get the exact area. For that matter, if you use the area of a triangle formula on a line, you would get the exact area. So Simpson's rule will not be an approximation. It will be the exact integral if you try to use it on a parabola, but at that point you should probably anti-derive.
Wait, would trapezoid rule work on like, so long as we have straight segments?
It would work on a piecewise function with straight segments connecting the dots, yes.
Yeah.
But I was thinking more like just y equals mx plus b.
Yeah, well that's obvious.
Yeah.
That would work.
That would work. The trapezoid rule would be the same as if you just made triangles or something, made a big triangle or something. But yeah, it's this is the same idea. Use Simpson's rule on a parabola, you get the exact answer. Now you know Simpson's rule, you can practice it, and you should also have a program for it in your calculator.
Yes.
Awesome. Okay, I'm going to give you guys some work to do with this, and we're going to stop talking about it here.
So are we done with the movie?
I think we're done with the movie. We are now...
Wrap it up, wrap it up.